I will continue with the same problem as before. Salsa production, number of jars of salsa to make, profit maximization. I had solved it and we had gone through a good portion of the interpretation of the ranging window. Where we stopped was what is a dual value. So we've run out of, if I make 540 jars of Western salsa and 240 jars of the Mexico City salsa, I will run out of whole tomatoes. I will run out of the 4,480 ounces of whole tomatoes that I have. So for every additional ounce that I get my hands on, from 4,480 ounce, if I have 4,481 ounce, then my profit, my objective function, which in this case is a profit, will go up or will improve 12.5 cents. So my 860 will be $860 and 13 cents. Same interpretation here for the paste. Keep in mind that our lower bound and our upper bound help us make conclusions about what the value of objective function will be. For example, original value or the number of ounces of whole tomatoes that I have available when I go into production is 4,480, but I can have up to 5,600 as my right hand side value for whole tomatoes, and my dual value would still be 12.5 cents. So instead of 4,480, let's say I have another 200 or 300 ounces. Let's say I have another 300 ounces. Well, another 300 ounces will put me at 4,780. 4,780 is still within this range of lower bound and upper bound. So because I'm still within the range, and because for every additional ounce I make 12.5 cents extra in profit, therefore 300 times 12.5 cents would be the improvement to my profit. So I can add that to my 860 profit, and that'll be my improvement or increase in total profit if I have an additional 300 ounces. The same interpretation can be made if your original value or right hand side decreases. So you can go from 4,480 ounces down to 4,320 ounces of whole tomato, and the dual value would still remain valid. What does that mean? If instead of if I have another 100 ounces, well, the 100 ounces is going to put us below this. So if I have 100 ounces less, that would make this value 4,380 and 4,380. Oh no, I'm still going to be within the range. That's good. So if I have 100 less ounces of whole tomatoes, my right hand side would be 4,380, which would still be within the range. And because it would still be within the range, the dual values would still remain valid. So because now I have fewer ounces than the 100 fewer ounces that I have multiplied by 12.5 cents, that would be $12.50 less in profit that I'm going to make. So my 860 minus the $12.50 would be my new profit estimation, assuming I do not have the total amount of 4,480 and instead I have 100 ounces less. So similar interpretations can be made, and that's what these ranges are called. These ranges are called ranges of feasibility because it tells us for what range in the right-hand side of the constraint is that constraint valid, meaning those dual values remain valid. And these upper ranges related to variables, these upper ranges from lower bound to upper bound, these ranges right here are called range of optimality because if the objective function coefficient of a variable falls within anywhere within that range, then we can say that the value or the optimal solution remains the same. So that's why we call it optimality range. Um, Reduced cost, briefly I will mention this. Reduced cost will be zero if the variable has a positive value. Now remember, all decision variables must be greater than or equal to 0, and that's our non-negativity. Oops, what did I do? And that's our non-negativity constraints. So decision variables can be 0, but if they're not, if they are positive in value, then their reduced cost would be 0. Now, reduced cost is just the terminology. It doesn't necessarily have anything to do with cost, regardless of what the decision variable is measuring. This column right here always will be called reduced cost. Reduced cost is how much the objective function coefficient of a variable, the objective function coefficient of a variable must be improved for that variable to have a positive value in the final solution. So in this example, the $1 and the $1.25 profit per unit for each jar of Western and Mexico City salsa are good enough or high enough that linear programming has decided to have positive values for both variables. And that's why the zeros for the reduced cost. In the next video, I will show you a problem where the reduced cost is not 0 because the value for the variable is 0. I hope you found this helpful.